So we have now learned that there are 4 things that we have to know, we have to have this prior knowledge in order to solve systems of equations using elimination. We have to know how to find perfect opposites. We have to know how to combine like terms. We need to know how to solve one-step equations. And we've got to be able to substitute at the end and solve for that second variable. And I started you guys off today with a system that's going to be pretty simple when we look at it, because perfect opposites are going to be right there in front of our face, and we're going to be able to cancel those out. There's going to be another video where perfect opposites aren't shown in the 2 equations, and we're going to have to create them ourselves. So when we take a look at these 2 equations and look at them carefully, what we're able to see is that we've got positive 10y and negative 10y, and those 2 things are opposites. They would come together to form 0, so we would be able to cancel those out. Okay, so now what we're able to do is we're able to combine our like terms. I've got a negative 4x and a positive 7x, and when I combine those together, I kind of match up the positives with the negatives, and I'm going to have some positives left over. That means I'm going to have 3 of those positives left over, so I'm going to write down positive 3x. On the other side of the equal sign, I'm able to go ahead and put 10 and 20 together. That creates 30, so positive 30 there. And now it's just solving a one-step equation. I teach all of my students to model these. We have 3 x's, and those 3 x's are equal to 30. And now what we teach is split that 30 up evenly amongst the 3 x's. And so what we realize is that each single x is going to be worth 10. And so we found our first value. Our x value is going to be worth 10. Okay, so when I put that in for my ordered pair, that goes first because x value always comes first in an ordered pair. Now comes the 4th step, and this is probably the most difficult for students, is making sure that they know to substitute that x value into one of the original equations and then solve it. So I'm going to go ahead and I'm going to erase what I've done here. I'm going to look at these 2 equations. I've got negative 4x plus 10y equals 20. I got 7x minus 10y equals 10. It doesn't matter which one you choose as long as you use an original equation. And so I'm going to go ahead, I'm going to pick the first one. So I'm going to rewrite it off to the side, negative 4x plus 10y equals 20. And what I'm going to do is I'm going to, just like a coach would for one of his players in a game, I'm going to substitute 10 into the game for x. 10 is going into the equation, x is substituting out. So really what's happening here is I have negative 4 times 10 now, plus our 10y's, and on the other side of the equal sign I've got positive 20. Okay, negative 4 times 10 is negative 40. So now I'm going to go ahead and I'm going to look at these as single terms. Negative 40, positive 10y, that's on one side of my equation. On the other side, I've got a positive 20. All right, so when I solve equations, I teach all my students, this is like a ping pong table, and the equal sign is our net. And we can ping pong anything we want, any term we want to the other side of the equation. The only rule that we have to follow is that it's going to change to the opposite. So my negative 40, I hate negatives. I want to ping pong those over the net. If I ping pong negative 40 over the net, what's going to happen is it's now gone from the left side of the table, obviously. And it lands on the right side of the table, but it lands now as a positive. It was negative, it becomes positive. That allows me to combine my terms on this right side. So I've got 60 now. And on the left side, I still have 10 y's. If I was going to model this, I would draw 10 y's out. All right, those 10 y's are represented by the number 60, which is a positive 60. And I've got to cut that 60 up evenly into 10 sections. And so that would tell me that each section is worth positive 6. And so we found our second value. Positive 6 is the other piece of our ordered pair that we needed. And so what we're going to do is we're going to take that piece, we're going to put it right into our solution box, and our point of intersection for these 2 lines would be at positive 10, positive 6. So I hope this helped. You can go ahead and try a couple on your own that work out nicely for you, that have perfect opposites right away. And then check out my other video if you're having trouble of creating your own perfect opposites. That's a little bit more difficult.